So today we plan to talk about social learning, and it's kind of the second big pillar in organizational learning. The first one being individual learning by doing. That's what we focused on last time. Today we're going to move from that to social learning, and we'll also include a second agent. So far we've been working with a single actor, right? Now we're going to start looking at dyads. Still keeping it only at the level of dyads, not going beyond the dyads. We will do more next time when we look at entire networks. But for now, we are just increasing it from one actor to two, which is, of course, 100% increase. So it's not a trivial one. But you will see already it includes thinking about a lot more complexity than we had before. Okay. And some of what we will spend our time today on is actually making sure that those sources of complexity and the kind of implications that has for organizational learning are well understood by everybody. So that's going to be our focus for today. In terms of agenda, I want to start by just keeping some time in the beginning for open questions from session one. So hopefully you all had a chance to reflect, think a little bit on what we covered, do the follow-on reading. Of course, we'll talk more about performance feedback and probabilistic search in a second. But if something is unclear or needs clarification from session one, let's first get that out of the way. Then we'll move on to talking about performance feedback. And in particular, I'm curious to hear what has been your thinking about how to incorporate that within the modeling framework of adaptive reinforcement learning. Okay, so I'd like to hear some ideas from you. We'll spend some time on that. Then I'll move on to reviewing some basic concepts, which should be familiar from the pre-readings, but I want to make sure we are all on the same page. So interdependence, particularly task versus agent. What does decomposability mean? Different forms of dyadic interdependence. What's the difference between interdependence and influence? And finally, we will close with the difference between vicarious learning versus coupled learning. Okay, and then we'll talk a little bit about how you might model this in the context of organizational learning. So that's kind of the overall agenda for the day. So let's start first with any open questions, clarifications, comments from the content from last session. Are we comfortable with all the ideas from there? Okay. So let me drill down a little bit on one concept which we touched on towards the end. Maybe there was enough time to get the key points across. Maybe there wasn't. Let's make sure that everybody is comfortable with this idea. We discussed two big families of models of individual learning by doing, if you like. One is the adaptive reinforcement learning using multi-armed bandit. The other is the NK model. And in the context of these two models, often the terms people use is search versus learning. Okay, so how in your mind now do you think about the difference between search and learning? Anyone? In what ways are they related? In what ways are they different? Are they the same?
I think it's for NK model, when you search, you kind of jump from the local search to a different place. Whereas the exploration in the multi-armed bandit model is to select which is not seemingly the optimal choice for the agent. Yeah, so I think that's the one difference between the two.
Okay, so this is a difference in how exploration is conceptualized in the two. Okay, so you're exactly right. In the multi-armed bandit, the exploration behavior is one where you don't take the action that looks like the current best in your belief structure. Whereas exploration in NK models is often the distance from your local neighborhood that you jump. So one is really about search, whether to search or not, if you like, and the other is where to search. Right? This is the basic difference in how these two models are looking at it. But what is search itself? What is search and how is it related to learning?
Is search like more a sampling of or more alternatives compared to what you have been looking at?
So search is specifically the generation and evaluation of alternatives. Okay. Now, how is that happening on an NK landscape? Every time you move, whether you move locally or you move globally, you are reaching a new point in the space, right? And that new point is an alternative. So that is the search process, which is made explicit in an NK model. Okay, the generation of those alternatives and the evaluation of those. Learning is simply change in behavior as a response to experience, right? Changes in beliefs and behavior as a response to experience. That's how we define learning. So what then is the relationship between search and learning?
So if there is no search, there's no learning.
So can there be learning without search? In other words, can you have a learning process where no new alternatives are being generated?
I don't think so.
Why not? Isn't that exactly what the bandit does? Right? We already know the alternatives. So the only question is we don't know their value. So we are changing our beliefs about their value and therefore also our behavior in terms of which one we select based on experience, right? So it's actually exactly the opposite of what you said. So all search involves learning, but not all learning needs to involve search. You see that? So all search must involve learning, because in an NK landscape, when you look in your local neighborhood and decide to move or not decide to move, that is a change in your behavior as a function of feedback. The feedback is coming typically from some offline process where you're trying to sample your local alternatives and understand are they improvements or not improvements. But you are changing your belief about the value of your local actions. That's learning. So all search involves learning, but not all learning requires search. Okay, so learning is the more basic category here between the two. So NK is focusing very much on the question of alternative generation and their evaluation. In the bandit models, we are mostly focusing on estimating the value of known alternatives, not coming up with new alternatives. Now, we already discussed this last time. We can merge the two by doing some modeling tricks. There are ways to bring the two models closer and closer together. So we can create a sense of space in bandit models by putting the arms in a network structure, right? We can also start with a large number of arms and give estimated values of very close to zero for a very large number of them, so that practically those alternatives don't exist. But they can come later into the game because of the relative attraction of other alternatives falling with respect to these very low but non-zero values, right? So there are different ways we can use modeling tricks to bring these features in. But the key point that is really important to bear in mind is a conceptual one. And the conceptual point is that search is defined as the generation and evaluation of new alternatives. Learning is about changes in beliefs and behavior through experience. Therefore, all search processes involve learning, but not all learning involves search. So learning is the more general term. Okay? Learning, when we say organizational learning, search is a subset of that, which involves changing your beliefs and behavior, not just about the value of known alternatives, but also of coming up with new alternatives in your representation of the world. Okay. Now, just to make things more interesting and confusing, people also sometimes use terms of search task versus learning task. Okay. So a little bit of disambiguation here. So the difference between a collective search task where a group is searching versus a collective learning task lies in what's being measured. Okay. So if you measure the performance of a group by the max performance attained by the best performer. So think about a situation like that, right? We have a group, they're doing some kind of learning process. They're trying to figure out either the value of things that are known or even discovering new alternatives as well. So whether it's NK or bandit really doesn't matter. The key question is, you're going to measure whether the group succeeded or not based on the best outcome that was accomplished by any individual in the group, the best performer, basically, right? What's a process that looks like that? Can you think of a collective learning process which has this kind of attribute? That in the end, all we care about is what's the best result they generated, and we don't care which individual generated it. As long as one of them did it, that's fine.
And more something like recruiters finding a job candidate, where one of the recruiters, as in you just need the best candidate from one of the recruiters, not everybody to perform optimally.
Exactly. So we don't need every single individual to converge on the same candidate, nor do they all have to find equally good ones. You find the best one, and as long as somebody in the team found it, the team has succeeded. Okay. I want to get a few more examples so people are comfortable with this idea. Can you think of some more?
Scoring a goal in football. you just need one person to score. You don't want.
Nice. Okay. Yeah, that's a good example. I like it. Any more?
Getting fundraising for startup teams. They just need to find whom to fundraise, but don't necessarily like one specific person to find it.
Okay, so anyone in the team, if they can do it, that's good. But I guess also we have to define the other dimension, which is it the max or not, right? So if we know that there is essentially one ideal investor for this company, maybe it's the Gates Foundation. So all it matters is somebody in our team is able to reach out and get the Gates Foundation to invest. So it doesn't matter like how many do it, or the other attempts they made don't really matter. What matters is the best outcome that you could get. Okay, R&D is a lot like this. So if you think about research and development, particularly think about pharma. So the blockbuster matters, right? So we need to find the best possible molecule that is going to give us the best therapeutic effect and economic value. But it's not necessary for every scientist in the group to have found it. As long as one finds it, the group has found it, right? And the performance of the team is going to be measured by that one best molecule they came up with. So when you measure group performance by the max, and it doesn't matter that all do it as long as one individual does it, then we can think of that as a pure search task. Okay, that's the language people will often use to describe a pure search task. We'll see this become important next time when we talk about organizational learning at the network level, right? Last time was at the individual level. Today we're going to diets. Next time we go to networks. But some of the most influential papers on org learning in networks are really not about learning in general. They are in particular about search tasks. Okay, and this distinction will help us understand why the results sometimes can look a bit strange compared to if the goal was learning as opposed to search. Now, to contrast pure search task with a learning task, here we care about cumulative performance. Okay, and we care about the performance of everybody in the system, not just the best. So we want everybody in the group to do well. What kind of a learning process looks like this? What would be an example of this?
Sorry to, ask a small question here. So does it mean only so how's it in logistically? So if the best performance works really, really well, like let's say someone scores 10 and everyone else doesn't score. So will it be a learning task, or everyone needs some kind of baseline to learn, like everyone needs to do something?
So that's the nature of the task, right? So if scoring a goal is like finding the trick to get past the defense of the other side, it's not an effort problem. Everybody's working hard, but it's a search problem because we're trying to figure out which is the best way to get the ball past the defense. As long as one person does it, that's enough.
Okay.
Right? So we don't need the others to be involved. Now, I don't know anything about football. It may be that there is no such single person strategy ever feasible. Maybe it's always a group play. I don't know, but you know the context better, right? But that's the spirit of it. Okay, now, so back to my question. So to contrast it with the R&D team, where all that matters is one person finds the blockbuster molecule, let's think about examples that are like group learning tasks, where we actually care about not just the best outcome, but the cumulative outcome over time. And we also care about everybody accomplishing it. So we really care about the average performance of the group, not just the performance of the best individual. Right? So if you want to run the contrast in your head, think about the R&D team as a team where they get 10 periods to play, 10 years, 10 quarters, whatever you like. And at the end, we're going to judge the success or failure of the team by what's the best molecule they came up with. And we don't care who came up with it. Now, the mirror image of that is another team which also has 10 periods. But at the end, we're going to judge the performance of the team by the average cumulative performance of every member in the team. So what does the second situation remind us of? What kind of context does that look like?
I mean, a relay race would qualify. It's not related to our discussion, but yeah, in relay race, you want everyone to perform to their best, and yeah, that's cumulative performance depends on everyone.
Okay. So the analogy with sports works as long as there's an element of search here. There's an element of learning, right? If it's not pure effort. So I hope you can see the difference there. In both the football case and in here, if the story is just about working hard, then we are not talking about learning. Learning means you are improving your understanding of the world. So if there is a particular way to run a relay race, maybe there's a particular technique, or the baton passing has to happen in a particular style or something like that, and people are learning that, then I think it qualifies as a good example.
How about top management team?
Say more. Why would that qualify?
Because I think they really care about the accumulated performance because because the firm performance the accumulated firm performance is more important, and also I think both the CEO, CFO, and all the top management members, their performance is very important. So I think it is consistent with this context.
Okay, so the group performance is naturally interpretable as some kind of sum of the performance of all the members, right? So if the top management team is a bunch of division vice presidents, for example, and each one of them is learning how to run their own business better, then this looks like a situation that would be in the bottom right corner, right? Yeah, I think this would work. Any others? Let's get a few more examples on the table so we're all clear on the idea.
The class that you're running. So the next iteration that you would do, you would probably want people to do much better in building organization learning models.
Okay, so you would want everybody to do well, right? That's the point. Exactly. It's not enough if one person writes an absolutely stellar model and everybody else kind of is not doing that great. We would not judge the class's success, right? So this is really a question of the perception or the filter applied by the evaluator to the group. So if the evaluator, which could be a person or it could be a selection environment, is going to select groups based on the best outcome they achieve at any point during the 10 periods, okay, then that's a pure search task. But if the selection environment is one which rewards groups for maximizing cumulative outcome and in aggregate across all group members, that's a very different selection environment. So when people talk about pure search versus pure learning tasks, this is what the difference is, okay? But conceptually, the point to bear in mind is that search is about generating and evaluating alternatives. Learning is about change in beliefs and behaviors. And therefore, you cannot have search without learning, but you can have learning without search. Okay, that's really the core set of issues that one has to bear in mind. Are we clear on this one? Everybody comfortable with this? Yeah? Okay, good. So let's turn to talking about learning from performance feedback and probabilistic search. So you've read the chapter that Vibha and Henrik wrote. In fact, I'd asked them if they can join today, but both are traveling, unfortunately. So they might come back later in the class when they're back, maybe in the last session. But I'd like to hear some of your thoughts firstly on, I guess, two separate questions. One is, first summarize for me what in a somewhat formal way, the way we've been using a formal language to talk about learning by doing. How would we formally describe probabilistic search and performance feedback? And second, can we use our existing language of adaptive reinforcement learning to incorporate probabilistic search and performance feedback? Anyone?
I think probabilistic searches, rather than using absolute criteria, but using satisfactory aspiration level to update or to do the search. And I think it's related to adaptive reinforced learning, as in the adaptive reinforced learning model, we used the gap between the feedback and our belief to update our belief. Mm-hmm. But rather, I think it elaborates more on this. So rather than the gap, we kind of used our aspiration level in the model, so that if it is above that, we don't update, and if it's below that, we do update. So there is some kind of variable we use our belief in the model for this model.
Okay, so these are the places where it might come close. Let's first do full justice to the way that the probabilistic search literature talks about it. Okay, then we'll try to move it into our world. So for them, what they're really saying is there is a construct called an aspiration level, which is at a particular time t, and I'm comparing my performance at a time t with this aspiration level, right? And if it turns out that this is greater, then what do I do in this theory? Nothing, right? Nothing. So I don't do anything. Nothing happens. On the other hand, if the aspiration level is greater than your performance, then you do something. What do? You search. Right? Search, we just discussed, is the generation of alternatives. So you look for new alternatives and you essentially decide whether to pursue one of those or not after, I guess, comparing it. Now, it's very important to bear in mind, there's nothing in this theory that says search will result in an improvement in performance. Okay? They're very careful to avoid making that claim. They simply say behaviorally, what we should see is people don't search as long as performance remains above an aspiration. That's the precise sense in which this is a theory of satisficing. Why? Because an optimizer would keep searching even if you're performing above some aspiration level, because you want to get to the global peak, right? You don't want to do good enough, you want to do best. That's the optimization theory. But the satisficing theory is captured here by saying, as long as you're doing well enough, you don't do anything. It's only when you fall below some aspiration level that you do search. This is basically the idea, right? You do search. Now, how is this constructed? Where does this come from?
It comes from two.
Oh.
Okay, lots of people jumping in. Good, that's a good thing. All right, Piyush first, then Shukti.
No, I actually had a question. Like,
Yeah.
when you say search here, do you also mean that, do you say that this is equivalent to exploration, or you say that this is generation of alternatives, not irrational action? Because
it is a generation of alternatives, right? It is a generation of alternatives. There's nothing in their theory which says anything about irrational action. Exploration is simply the search for new alternatives. It's other than what you currently are doing. That may or may not be better. It may sometimes lead to worse outcomes. It might lead to better outcomes, but it's doing something different. Therefore, it is an alternative generation.
Okay.
Yeah.
Because as in at least Henrik's initial paper, when he talks about it, it says that you take risky action, and that could be both, right? It could be that you undertake an action which you are not aware of, but it could also be that you undertake an action that you were aware of, but you felt that this was more risky than what you would take normally.
Right. So that is an elaboration. And in fact, if you read carefully the many papers that are reviewed in the chapter, they all have slightly different takes on this. But I'm referring to Sayat and March 63.
Okay.
This is the original formulation of their theory, which is essentially, if performance is above aspiration, you don't do anything. If it's below, then you search. That's why it's called probabilistic search, right? It's not called probabilistic risk taking. So it is probabilistic search. Now, what that search means is obviously going to be important. And people have operationalized it, I think, in slightly different ways in different papers. So we'll come to that in a second, but let's just go back to understanding the other elements here. How do we construct the aspiration level?
So it could be either based on my own historical performance or based on social comparison with whoever I consider to be my peer.
So this is the reference group, right? This is some reference group that I think is the relevant one. And of course, it's my own historical performance. Okay, good. And in this sense, already you can begin to see that the moment you allow for this, we are already now in the world of social learning. In the very minimal sense that others' performance has an impact on my own behavior. Okay, so in a very, very minimal sense, this is already social learning. We will make it richer as we go along today, but this is kind of already a basic point. So to precisely avoid that complication at this point, for the next few minutes, let's ignore this. Let's assume that the only aspiration that matters is my own. Okay, let's stick with that very simple model. So let's go back to Piyush's question now. So what's your understanding of what search then means? We could have different interpretations, but let's hear them all. So if you are falling below aspiration level, you search. What does search mean? What do you do?
The way I was thinking, it is more as a more exploration. So the tau in our reinforcement learning model would be higher if the performance is lower than aspiration.
Okay, so you're connecting it already to the ARL framework. Okay, yeah, that's fine. But let's first make sure we are understanding their argument in their terms, right? So in their terms, how do they think about this? This is one of the interpretations, and Henrik's paper definitely has an interpretation. Are there others besides this?
I think they mentioned like about local improvement, which makes me think about the NK model where you search the nearby alternatives.
So probabilistic search is often local. Is that the idea? Okay. So when does search become non-local? Is that something covered in this theory? Is there something we can derive from this theory about when it becomes non-local?
It also mentioned that if you have like multiple failures in a row, you might want to go for distance search.
So it gradually can become global, right? If you're continuing to fail to meet this condition. So notice already that this interpretation and this interpretation are exactly opposite to each other. Okay, if we use the word exploration for either taking an action that's not the current best or taking a distant action, okay, then these two almost seem like mirror image opposite statements about what's going on. My point simply is that some of this ambiguity is simply because we have not been very careful about defining exactly what we mean by these terms, right? And there's a lot of in any given paper, it's well defined. The problem is across papers. So different authors may end up using slightly different definitions. So when you are trying to pull it together, as Henrik and Vibha tried in their heroic exercise in this chapter, you can see they're really struggling to put all of this into a framework that makes some cumulative sense, right? Because the way people think about how to measure aspirations, how to define search, and even there are papers which actually argue the opposite of this under the rubric of slack search, right? There are special circumstances where you might not get this behavior, you might get something else. So there's a lot of variation in how people on the ground then operationalize this broad theory in terms of concepts and stuff, right? Any other ideas on search besides increasing tau versus local or eventually global? Is there any other way to think about search? Shukti?
Phanish, I had a question. So in all this conceptualization, like when is exploration enough? Like when does it stop being local and jump to exploration? Like from a modeling perspective, how do I think about it? Is it like, because when I'm like fitting parameters, when like somebody can argue this is not far enough. So how do you make that distinction?
So it depends on whether by exploration you mean tau or you mean distance. Firstly, let's clarify that, right? If it means tau, then essentially the more risky the action you're taking, because it looks less attractive given my current beliefs and you still want to do it. So a measure of risk-taking maps quite closely to exploration if exploration is defined like this. If exploration is defined as distance, then you have to first define some space. So for example, if it's diversification, then we would say unrelated diversification is more exploratory than related diversification. If it's patenting, then you might say patenting in a class that you've never patented in before is more exploratory than a class that you've already patented in. And papers have done that, right? Many papers have used exactly this kind of idea. So depending on what your definition of exploration is, if it's tau, it's going to be correlated with risk-taking. If it is distance, it's going to be correlated with some metric of distance in some conceptual space. So you have to first define that conceptual space, then measure it, and then it will be a measure that correlates with it.
So is it almost like risk versus knowledge? Like in the second, are we saying that the distance is more a measure of knowledge that you're not familiar with? In the first, it's more like rationally that would be a more risky action to take. It has got nothing to do with knowledge. Like
but does it have nothing to do with it? I mean, that's the complication. Often these are correlated, right? So the things that are further away from your current comprehension are also likely to be the ones that you know less about, and therefore also may appear more risky. So distance and risk are going to be correlated in many circumstances. That's the reason why in the end both are called exploration. But conceptually, you're right, they're different. I can do a 2x2 and give examples where it's distant but not risky, right? And risky but not distant. Yeah. But the correlation between the two constructs is not zero, clearly.
Yeah,
right? It's positive and quite large. And that's the reason why in the end people end up using the term exploration interchangeably for both. But we should not. That is also exactly my point. We should be more precise.
So what is the risk based on then?
So imagine you have a belief structure which says I have two actions. Okay, I know I pull action A, I will get a sure reward of $1. Okay, action 2, I don't know either anything about it or I actually think it's likely to give me a lower payoff. Likely, but not guaranteed. So I am taking a risk by pulling the second action, right? I should just, if I'm risk averse, I should stick with what I know and pick the action that I know will give me $1. Okay. So that's the sense in which risk-seeking behavior can be interpreted as a form of tau, right? Yeah. Whereas distance-seeking behavior or long jumps or kind of movement far in the landscape can be thought of as a measure of distance search. But of
Yeah.
course, the more further away you go from your knowledge domain, it's also the case that you know less.
Risky. Yeah.
That's the reason why the two can end up being correlated.
Okay. Thank you.
Yeah. Piyush?
No, as in, I just wanted to highlight, like, I think the reason why people conflate the two a lot is also comes from like Jim March's 91 paper, where he specifically defines exploration as things that are distant from you, whether spatially, structurally, or knowledge-wise. So I think, yeah, that's all I wanted to say.
That's where it comes from. That's right. But actually, interestingly, the exploration exploitation trade-off that he was citing, and he cites John Holland's paper in his 91 paper, that's all from bandits.
Yeah.
Right. So the original exploration exploitation trade-off actually comes from bandits. So this has been like a pretty painful thing for the field to come to grips with. Even in the modeling community, I remember like about 7 or 8 years ago in the Tom Society meetings, we had this big debate about like, should we standardize terms and get rid of this confusion? But we're not the Soviet Union, so we cannot standardize terms and issue a handbook and say we now all follow this. But okay, you can call it whatever you like. In the end, it's naming, right? But we should be clear, what do we mean? And I will suggest you read a recent paper by Stefan Willinger and Kannan Shrikant, who's a former student of mine, and Niels Stiglitz. It came out in SNJ, I think, quite recently.
Is it an experiment?
It's an experiment. But what I really like about the paper, in addition to the experiment, is that it also very cleanly separates these points. Right? And what is interesting is they are able to do that within an NK framework. So in their world, what they say is there's a stage 1 decision on whether to explore, and the second is where to explore. So the whether is like the risk taking. So effectively, they're arguing that we can treat tau in bandit as equivalent to the decision whether to explore in NK. We may or may not agree with it, but what I like is they're super clear about the fact that deciding to do something risky and where to do it are two separate questions. Right? And they're able to measure this very nicely in their experiment and show that the antecedents are not the same. So for that reason, I think this is a good paper to read. I think Samir has just put it in the chat as well. Yeah, Pulkit, go ahead.
So when we say risky, do we talk about the variance or the expectation?
In this case, it's basically it's Knightian uncertainty, really. People have even like estimates, reasonable estimates of variance.
Okay, so Knightian. Okay.
It's really true uncertainty, structural uncertainty.
Okay.
So risk is really not the right term, right? So that's why this is an imperfect analogy. But you can think about it as doing the thing that you're less certain about. Okay. Any other thoughts on the basic theory of probabilistic search? We will turn in a second to how we might formalize it in our framework. But do we want to add any comments? Any thoughts on the chapter itself? What you got out of it besides what we just put on the board? They also have some nice discussion at the end about potential future directions. They also point to places where things are somewhat unclear yet in the literature. So what's your take on that?
One of the things they highlighted was that group level research will inform a lot about how organizations work rather than studying everything at the firm level, which kind of doesn't consider aggregation issues, for example. And also group level dynamics might be important if you think about, like, this is also related to this week's reading, which was about conflict, right? Which is much under theorized in organizations per se. And so they talk about things like multiple goals and all the things that are potential sources of conflict, but have been almost treated uniformly and ignored in studies so far. So yeah, that was useful.
Okay, no, these are valuable points. I agree. So it's interesting. So much of the literature on performance feedback and probabilistic search is really at the level of the firm, treated as a single actor. Okay, so at least from a theory point of view, they are really theories of individual behavior, not necessarily organizational behavior. In fact, it's not even clear what would be different if these were individuals versus they were groups, they were firms, right? And that may be a good thing, because essentially they're saying if you look at the individual level goal setting theory, it makes very similar predictions. Okay, not everything is identical, but there are strong similarities, as they're pointing out in the chapter, between goal setting theory at the individual level and probabilistic search at the firm or the group level. Okay, now let's think a little bit though about the original paper by Sayat and March. What was their reason for assuming this structure? It's not a psychological reason, right? The Syed and March is not about the psychology of individuals, though they are drawing on research on psychology of individuals. They are making an assertion that this is what groups will do, the group being the firm in this case. So why is it that when performance is above aspiration, nothing happens? Yeah, go ahead, Shruti.
Is this related to satisficing? Like in general, if you're not a optimizing or rational agent, then you have no reason to take any action. You're well below the aspiration level, and it's like a satisficing action, right? There is.
But that could apply to individuals too. So is it the same when it's a group? Is a group of satisficers just the same as an individual satisficer? Is there something else that happens in groups in addition to the fact that individuals, of course, satisfies? But is there a group effect that may make this phenomenon emerge? Let's translate it into plain English, right? What this really means is if things are going well, don't do anything. Don't rock the boat. So think about a company's top management team and they are, considering alternatives to do some radical different thing. They want to search. They want to change what they're doing. It could be a diversification. It could be an M&A. It could be an expansion of some kind. And what do you need as a group to be able to do in order to agree on a change like that?
I guess consensus.
Exactly. You need everybody to agree, right? And it's going to be hard to do that in a circumstance where people can argue that what's the problem now, right? So the fact that there is a status quo bias created by the group need for consensus is really driving in their story why you get this effect. So it's not just that let's just assume the group is like one big satisficer. They're more sophisticated than that, right? So they're saying there is a group level interaction effect, which actually leads to some interesting predictions. So you would think if that's the case, this effect should get weaker the more concentrated the power in the group is, right? Because if it was a group that requires consensus, then this effect is, let's say, at a baseline level. But suppose it just requires one person to make up their mind. Then we are back to individual satisficing. So you don't have this consensus constraint. So in that case, this probabilistic search effect should get weaker. That's a prediction. I'm not saying it's true, but it's a prediction that follows once you think about it as a group as opposed to an individual. So this is completely testable. One can look at top management teams and look at the power structure in them and try to see if our existing results on how top management teams search or not probabilistically are moderated by the power distribution in the team. This would be an implication. Now, I don't know if this has been done because I don't follow that literature, but if you're interested in studying this domain, I think I would certainly encourage you to think of this as a general heuristic. Take any result on top management teams and ask how would the main effect be moderated if we accounted for power distribution, right? Something has to change because it is no longer just a single individual making a decision. A group has to agree. There's got to be a consensus of some kind. So that might be a generally good idea for generating new questions one can take to existing data. And this is like a one-step neighbor of an existing paper because everything else already exists. You just want to test the one additional idea here. Okay. Other thoughts on probabilistic search and learning from performance feedback?
Finish about the social learning and about the social aspiration level. And especially when you talk about this group level kind of conflicts or the consensus, I think your reference group also can be kind of different across groups because if it's in your past performance, that's your aspiration. That's easier, I think. But is there any thoughts on this? Like,
no, it's a great question. I haven't thought about this before until you mentioned it, but you're absolutely right. If you're a group with equally distributed power, then the historical aspiration for all of us will be the same. Yeah. But our reference group need not be the same, right? And therefore, effectively, each individual's aspiration level can be different from the other. And if this happens, then is the organizational aspiration level the min or the max or the mean? I don't know. I think it's a good question, right? So this is exactly what I mean by once you stop thinking in terms of unitary actor, but in terms of aggregation, then these kind of questions arise. And I think this can also be empirically tested. For example, if you see the top management team has extreme homogeneity on backgrounds, this would indicate that their reference groups are likely to be similar. Okay. On the other hand, if there's a lot of demographic diversity, I think it's a reasonable bet that the reference groups are probably likely to be different. So again, we can use team compositional diversity as a moderator of a known effect of social aspirations. Okay. I'm not at all sure that the two things I just mentioned haven't already been done. It's possible they've been done. So I don't look at that literature very closely. I mean, Goli would know, right? The person to ask would be Goli. But I'm suggesting a general apparatus for generating questions like this by moving away from unitary actor to start thinking about the aggregation issues in the group. So that hopefully is more generally useful. So here's my question to you. In probabilistic search and learning from performance feedback, where is the learning? I'm seeing a lot of discussion about search. Where is learning in this system? Is there learning? Would you say these systems that behave according to these rules, they are learning? They are, right? They meet the condition. They change their behavior as a function of experience. So you get experience in the form of payoff and they change their behavior. So it is learning. So what's not here explicitly is belief updating. Okay. That's what's missing. So there is nothing here about the belief structure that people have and how those get updated. That's all kind of hidden at a more abstract level in the story. Okay. It's almost as if there's a black box where beliefs are being updated based on this. And as a result of that, a new search strategy gets spit out and you observe that, but you don't directly observe what is happening to the belief structure itself. Sangyun?
I think it depends on how we define like beliefs, right? If we like define beliefs as the relative attractiveness of the current actions to the like task in the other options, they still update beliefs, right? By observing the others payoffs or the historical payoffs, they can like somewhat infer about the task environments, and that's why they can like deviate from the current action to find a better one.
So that's fair, but it's at a super course level. It's just basically the belief structure is do what I'm doing or do something else. But the do something else is not broken down any further.
Yeah, if we define like belief as a just limit belief as its attractiveness of its actions, but it's fine. I think that's correct. But the like to induce the changes in behavior, at least their beliefs should be changed, right? Their beliefs about the task environments, right?
Correct. So essentially, if you can interpret this as a two-armed bandit model where one of them is status quo and the other arm is search. Okay, just two arms. And effectively, what you are doing is you're updating the relative attractiveness of these two. So I would agree that in that very coarse sense, there is some belief updating, but nothing is being updated within this box. Right. So we have no way of telling good from bad search, distant from local. None of that is really part of the belief updating process. So yeah, I think that's a reasonable way to think about it. Neti?
Can we also link this with like organizations? They may have multiple goals and multiple aspirations level, and that may trigger like different learning behaviors. For example, like in workspace, do they learn from, or do they like learning by doing dominates, or social learning dominates?
So say a bit more about that. I'm not following the link to the social versus individual learning.
I mean, like, for example, if your goal is like innovation, maybe it's more about learning by doing because you need to do some R&D work by yourself. But say if the goal is more like financial profitability, maybe it involves a lot of social learning about like the best practices to improve efficiency.
Okay, so now you're saying let's reintroduce social aspirations here, and you're offering a theory about the relative weights between these two, individual aspiration versus social aspiration. Okay, we could go there. That could be one direction in which to go. In fact, when you read that chapter, the sense you get is that there's a lot of heterogeneity in the circumstances when social aspirations matter more versus own, right? And there's also heterogeneity in reference groups. And there's also heterogeneity, I guess, in the sense of how to combine these two. social and individual. There are different models, and I think there's some back and forth on which one seems to fit the data better. So the thing that just generalized across this body of work, I think, is this core idea seems very strong, right? That is pretty robust, I think, that people generally do not engage in search or exploration, either sense, unless your performance is actually falling below some threshold. That general idea is the one I think that has the most broad support. But then the specificities of when do the social versus individual aspirations become important? Is the search local or global, or is it just risk-taking? This seems to vary quite a lot by study, right? Different papers have taken different approaches to looking at this, but I like the idea you're mentioning. So when we try and formalize this, let's come back to that. Yeah, Jungyo?
I just have a clarification question about constructs we use. And I was wondering if learning only includes changing beliefs, or it also includes confirmation of belief. So if it did a search and did not change belief, an existing belief is right, is it search or not?
No, so learning is any change in belief or behavior, right? It's at least in belief, maybe also in behavior as a function of experience. Confirmation is a change in belief. It is reducing the variance, even if it's not reducing the mean, because it's increasing your confidence in your belief.
Mm-hmm.
So that's also a form of belief change. So beliefs are not only the first moment, right? We can take the second, third, fourth moment. So any changes to those are all changes to beliefs. So confirmation is a form of learning.
Thank you. And other thing is, I was just confusing search and exploration, and if it is the same or different.
So would somebody like to give us a summary now? How do you now think about search versus exploration? When are the two the same? When are they not the same? Anyone?
So I think search could be defined a couple of ways, which is like either creation of new alternatives, or it could be going some distance away, whether it is nearby or farther away. It could be either one. And exploration is taking an action which is risky or could be like farther away. So search could be just exploration, but it could be something else as well.
Okay, so search is a generation of new alternatives. Okay, and that new generation of new alternatives could be explorative in the sense the new alternatives could be quite risky. It could also be distant in the sense the new alternative could be very far from where you are. So the confusion comes from using the same word search for both, right? Or the same word exploration, to be precise, for both. So I would say the hierarchy of concepts that make it probably the easiest to bear in mind is something like this. So let's say search means new alternatives. Okay. Exploration could mean two things. It could mean risky among known alternatives, or it could mean new distant alternative. This interpretation is used in bandit models, adaptive reinforcement learning models. This interpretation is used in NK models. Okay. So yes, as a field, we've kind of made a mess of it, actually, to be blunt. So we could have done better. But this is the path dependence, right? So we now are stuck with these terms. So that's what we have to do. I don't think there is any controversy in this first statement. If you say search is about the generation and evaluation of new alternatives, nobody will disagree. And as long as when you use exploration, you tell me which one, that's also fine.
Thank you very much. And just one quick question is, how do you say how do you say exploring existing alternative, non-alternative in terms of search related term?
Here, this one has a new different alternative. This one.
Above that.
So search is just a generation of new alternatives.
Yeah, well, how do we link search and exploration of existing options. Like,
so you don't. What you say is, if it's a new alternative, it is search, but that new alternative can be very distant or can be proximate. Right? So the extent to which the search is explorative is captured by the degree of distance, but it's always new. That's why it's search. Right? As opposed to it is exploration in the sense you have a known set of alternatives, but you take the alternative that is not currently expected to be the best. That's exploration in the bandit sense. So as long as you say very clearly which of the two you're going for, and I think the easiest way to do that is to signal up front, is your model one in which the alternatives are all known, but their values are not? Or is your model one in which the alternatives themselves are being discovered during the process of learning? Right? In which case, if it's 2, then we are thinking search, we're thinking NK. But if it's 1, then we're really thinking something like adaptive reinforcement. Okay. All right, let's take the next step and say, okay, now we have kind of sorted out what the original theory of probabilistic search and performance-based feedback is telling us. How do we convert this into the framework of adaptive reinforcement learning? Can we, firstly, and if yes, then where would we do it? So let's go back to the basic elements of the adaptive reinforcement learning model. I would now encourage us all to start thinking of these as like Lego blocks. Okay. Sorry, there's one more thing I meant to say, I'd forgotten. So do you remember this results, which I think you were supposed to replicate last time before you came to class? So I hope you did that. I wanted to point out something interesting here, which you may or may not have paid attention to. Look at the difference in performance and search success that you got when you replicated these results, right? Did you notice that? So the search success numbers at the peak only go up to about 60%, whereas performance is clearly around 80%. How do we get that? How do we explain that? Why are these two different? Like, how is search success defined in this model? How is it computed? And how can we get a different value for performance and for search success?
As in, it could be that you are still at a higher among the different alternatives, but you are still not the best.
Okay, so it could be that you find good but not best peaks, good but not best arms in the bandit landscape. And that can still give you pretty good performance. But if you ask, did you actually find the global peak? That's what the search success measure here is doing. And it says, actually, you're not finding it very often. But it's not such a big bad situation, because performance on the whole is still pretty good. Now, what do you think will happen to the distance between these two graphs if I change my delta? Suppose I were to tune delta down, right? So remember, delta is the upper bound on the payoffs for the non-1 arm. So one of the arms has a payoff of 1, the rest are in 0 delta. Okay, so delta is 0.5, which means your payoff distribution basically looks like a bunch of things between 0 and 0.5, and there's one arm with a payoff of 1. Suppose I made delta actually go up all the way to 1, so that now the arms are like on a uniform distribution from 0 to 1. What would happen to the difference between these two? Would it go up or would it go down?
So wouldn't all?
I think the
Who wants to take a shot?
As in, it should go up. It should go up because you can be, as in, it's more likely that you will get stuck in local optima than find a global optima.
Okay, so there's a higher chance you're going to end up. Now, what happens if I start tuning the tau at this point? If I turn up the temperature, which is tau, and I make the agents more explorative, will I make the difference become larger or smaller? We don't have to wonder. You can run these experiments.
Smaller.
Okay?
Yeah, small, as in, yeah.
Yeah, it should get smaller because you're going to get unstuck, right? So you need to start thinking about these models using these basic building blocks. So you should be able to, in your mind, after having done it enough in the computer, you should be able to run the simulation in your mind that what's going to happen if I tune up the phi. So in this model, what do you think will happen if I increase phi? I'm going to get more likely to get stuck because I take my recent feedback and use that heavily in updating my belief. What happens when I increase tau? I'm less likely to get stuck, right? Conditional on being stuck, is my performance going to look good or bad? That depends on delta. Okay. So you need to be able to do the kind of mental calculus of how these parameters shift things in this simple model. And the best way to do it, to build that intuition, is just run it. Okay, put them through loops if you like, or just do it. In fact, the learning as an appreciator of what's going on is actually better accomplished by making one change at a time and playing it like a video game. Okay, that will help you understand better. If you just get the whole thing out as a batch process result and look at the graph, it doesn't stick. It's much more fun when you do local search yourself in parameter space. All right, that's what I'm suggesting you do. So try local search in this parameter space and then try to figure out what's this shape of the performance landscape as a function of delta, phi, and tau. I also wanted to flag it because this term we use here for search success is one more source of confusion, for which I will apologize. But we are using search here not in the sense in which we talked about it so far. There is no alternative generation in this story. Right? All alternatives are given. S is equal to 10. So what we could have instead called this something like the frequency with which the global peak is found. That would be the precise term, but that was a mouthful. So I think we were lazy and we called it search success in the sense, did you find the global peak? That's what we're really asking. But there is no alternative generation going on in this model. Okay. So Sangin, just a note for the code, maybe just change this label to something like global peak. That's more transparent, right? How frequently have you found global peak? So you can see we are also, in addition to my critiquing everybody else, I'm also contributing to this confusion myself by using these words somewhat interchangeably. But as long as we define our terms, at least there's consistency within the paper. It does make it harder, I think, to aggregate across papers. And that's why you can see Henrik and Vibha had quite a tough task on their hands to pull all these different papers together and still draw some interesting insight and pattern out of it, which I think they did. So it's a very useful reference chapter. Okay, so let's look at our model elements and now ask, where would I change this model to incorporate probabilistic search and learning from performance feedback? So should I change the task environment in some way? How so? How should I change the task environment to be able to capture the essence of probabilistic search?
Maybe if you're defining search as generation of new alternatives, then the set should not be a fixed set, but it's something that keeps on updating based on the performance.
Okay, so we should at a minimum have something like a way of expanding the alternatives that are de facto considered. Okay, even if de jure they are always there, they can be de facto not considered if they are effectively not very attractive. But if that can change over time, then effectively it's as if new alternatives are being created. Another way to do it might be to think about introducing some kind of a proximity function or spatial function between the arms. Right? So you might be able to create like a local neighborhood versus a global neighborhood. So alternative generation would be something like looking beyond the current one, only within the local neighborhood, or alternative generation can be long distance, where you look at things which are very far away. Okay. But essentially, to make it truly a model of search, we need to find some way of saying new alternatives can be created. So that's the first step. So pragmatically, do you have ideas on how one might do it in this model? How might we actually end up creating a situation where alternatives kind of enter the story at different points in time?
You can differentiate the M, so giving n sets of alternative and mapped into M, which already have.
Yeah, so you can start perhaps with like a big set of, let's say that you have like 100 alternatives, but to begin with, you only play with 10 of them, right? And every time this aspiration search process kicks in and you're doing poorly, you might then sample out of the remaining 90 at random, right? That would be a straightforward way of introducing some kind of alternative generation into this story. So expanding the set of potential actions that we take, starting initially without having the full set available to us. So this is one place where we can make a change. All right, how about this? This is our second element of the model, which is how do we represent the task environment? What is our belief structure? How would we go about now incorporating that into the ARL model?
Can we say that? I'm sorry,
Go ahead,
Parish.
Nettie.
Okay,
No,
thank you.
go ahead.
Can we say that if the agent takes an action and then the outcome is lower than the expiration level, he will adjust the representation of that action to a lower number of outcome. So it means he thinks this action may not generate a good outcome.
Okay, so you sample something from here, and when you sample it initially, you need some prior on it, right? So you have to have some belief on what it might be. And depending on the payoff, you may then update the prior using the standard reinforcement learning kind of rule. Okay, you could do that. Do you strictly need to do that for the probabilistic search and the performance feedback theory to be captured? Actually, you don't, right? Nothing in the baseline theory says you need to update the beliefs about these new actions that you sample. All you really need is to take that new action and compare it again to your aspiration level. And if it's good, you can stick with it. If it's not, you search again from the remaining 89. Right? But if you wanted, you could incorporate here this additional element of now maintaining like a belief structure about not just the 10 you have, but also the new ones that you have and updating them over time. So updating of beliefs could be added into this model at this stage, but it's optional. It's not strictly necessary. Okay, you can do it here. Any other ways you can think of bringing in probabilistic search performance feedback ideas into this part of the model? That's probably the, yeah, go ahead.
Could we do something in how the aspiration levels are constructed, for example?
Okay.
So based on like my own historical performance, then every time basically the aspiration level, like the threshold goes up, unless I'm performing below, and then
yes,
yeah, like readjusting. So use like a loop to readjust the pi star t every time.
Okay, so one of the things that we will have to add to our model in order to explicitly make it a model of probabilistic search is our representation should include not just the difference between the 10 I know and the 90 I don't and how that changes, but some sense of what is an aspiration level, right? So we will need a variable for aspiration level, which is captured here, and that could be updated either as some function of my own history. Let's just stick with my own history for now. We'll get to social learning in a second. And that will have to be updated. Right? So even if you don't update beliefs, you do need to update aspirations. You might additionally also update belief structures about the value of these actions. That's up to you, but you don't need that. What you definitely need is some way of updating the aspiration level. Okay. All right.
As in why do we necessarily need to update the aspiration level? As in,
aspiration levels are assumed to be a function of history. That's how they're defined in the original theory. I mean, you can have fixed aspiration level, I guess, as a special case, but that's really equivalent, I guess, to a zero updating of aspiration level special case. In general, aspiration levels are expected to be changing over time because of your history. Okay. Right? So you need some way of modifying what your aspiration level is going to be in this model. Yeah, Pulkit?
So that means search process also, the exploration process also impacts aspiration level. It's a feedback loop 4, right?
So we have not yet got to the exploration part in this model, right? We have simply defined the task environment. We have defined how we update our belief about it, which is at least the aspiration level must change. And over and above that, you might also change your belief about the value of these actions. But let's get to your question, which is, given these beliefs, we need some system of choosing. Okay. And now we have a way of incorporating in this model, one model of exploration, which is to take actions which in your belief system don't necessarily have the best payoffs. Okay, so we could do that. That would be one way in which to do it. So how would I take into account now the basic probabilistic search model into this choice function? How could I incorporate it here? Do I need to change anything, or is it fine as it stands? Pulkit?
I mean, something needs to be changed, but I don't know how we can just change something to match the aspiration level, because we need to, because if the aspiration levels keeps on fluctuating, so how does this P function changes?
How does the which function? Sorry?
The softmax rule. So are we still going to use it, or are we going to tune it in some way using tau or something?
Okay, so the first thing to bear in mind, remember our discussion. What is tau doing here? it is capturing exploration, but not necessarily search. Correct? So if we want to change our theory from probabilistic search to probabilistic exploration, then we know how to do it. That should be straightforward.
Yes.
How would we do it? We would make tau contingent on performance with respect to aspiration. Okay, but that's not a model of probabilistic search. It's a model of probabilistic exploration. Okay, now we can see why it's important to get the words right. Otherwise, we can easily confuse ourselves and our readers as well. So we can do that. And I think that's actually an interesting model to explore. Okay, in fact, I think we have run this for some other project. It may be in the paper. I think I pulled out this picture from the paper you read for today, the complexity paper that Sangyun and I wrote. So we have some results there in which we allow tau to change over time, okay, as a function of performance. So it's not fully a aspiration driven change in tau, but gives you some sense of the dynamics of what happens if tau is itself contingent on past performance. Okay, so it is equivalent to an aspiration level, where aspiration level is defined just by prior period performance. That's a special case, but that's the one we already have modeled, and I'll show you those results. But you could easily modify this model by having exploration contingent on performance falling below aspiration level. That would be the basic change. Search contingent on performance falling below aspiration level was captured in the previous stage, where you sampled new alternatives. Okay, this would be exploration contingent on performance falling below aspiration level. You could try comparing both. This would be an interesting exercise, right? So what do you think will be the difference if you stick with probabilistic search versus probabilistic exploration? And we have the apparatus to do it, right? You can set it up and see what difference it makes in terms of final outcomes. And then last but not the least, we need some step for changing our beliefs about the world. Now, if you were not modeling beliefs about actions, then this is unnecessary. Okay, but if you were keeping track of your beliefs about the attractiveness of these new actions you discovered, then you would need some system like this. You could use the standard ARL model to update it. So to recap, the simplest possible set of changes we might make to use our current model to start representing the probabilistic search and performance feedback world is first to expand the alternative set into things you know versus things you don't know. Okay, the new alternatives come from the second bucket, and as they enter the first bucket, the new bucket either replenishes or stays or gets smaller. This is a modeling choice you have to make. Second, you want to maintain at a minimum a representation of your aspiration level, which will be updated over time based on your past performance, right? This is at a minimum what you would need to do. And third, you may or may not want to have any exploration in the choice step at all. In fact, you can set tau close to 0. You might completely max on the alternatives once you have included them from the bucket of things that were unknown, right? So you need some belief structure about what those things are worth, but you don't need to update those beliefs. And as long as you have that belief structure, I can just run it through softmax again. And finally, if you're not interested, you don't have to update your belief structure on these. Okay. This would be the simplest possible way of taking our existing model and incorporating performance feedback theory or aspiration-driven search theory into it. If you wanted to take it in the direction of aspiration-driven exploration, then we might again change the task environment. We might update aspiration level, and we might now change our tau to be a function of whether performance is above or below aspiration. So tau can be scaled up or down. And this would be a model of probabilistic exploration, not necessarily a probabilistic search. Okay, that's a variant on the model that we first had. So these are like two ways in which you can branch out with this and try and link this to the literature on aspirational search, to probabilistic search and performance feedback-based learning. All right, Piyush, go ahead.
Wouldn't we also want to change the learning rate to somehow include the aspiration level there? Like if the performance is above aspiration level, then you do not update.
So it depends on whether you want to update your beliefs about actions. If you don't want to, then you can just set phi at 0 and you will still get a model of probabilistic search with performance feedback. Can you see that? So if I start with some initial priors about actions, and the only time I kind of need a new prior is when I get one out of that bucket of 90, which was untouched so far. So I can pull out one of the actions there and I can randomly assign some prior to it. I don't really need to update anything. right? I can just take, so let's actually work through the model in one run of it, just to see what it will look like. So let's look at the pseudocode of it. So we start, let's say with, let's make it very simple. I have one choice and I have a bucket. And the bucket is very large. It can have, let's say, up to 10 choices. Okay. So in my first period, let's say I also have an aspiration level, which comes from somewhere. I have an historical aspiration level. So I look at my performance and I compare it. Is it like equal? Is it greater than, or is it less than? Okay. So if my performance is above aspiration level, what should I do in this model? Nothing. I should keep pulling the same action, right? Suppose it's below my aspiration level, what should I do? I should reach into this bucket and pull out one more action, right? So now I have two actions. I have action one and let's call this action two. Okay, and I still have my prior for action one, and for the new action two I pulled in, I will need to assume some random prior. So I have some belief about its value. Now, given these two, I can softmax over these, or I can just max. It's up to me, right? If I don't want to model exploration at all, then I don't need softmax. I can just max. I can pick whichever seems better to me. And then I can again compare my performance with aspiration level. Is it better than, is it equal to, or is it worse than, right? And if it turns out it's worse, then again, I go back in and I pull out another action. So now I have three. So you can see over a period of time, my alternative set will get larger and larger. My beliefs about them don't necessarily change, right? But this is still a model of learning. That is a beautiful point, because it is a change in beliefs or behavior. And my beliefs are changing in the sense my belief for a given action is not changing, but my set of beliefs are changing because my set of actions are changing. Right? So even if I'm not updating the belief for any given action, this is still a model of learning, because I'm changing my total belief vector, which went from one action to 2 to 3 to 4 to 5. My belief structure is changing. My behavior is changing because given my actions, I'm going to pick something. So it's a model of learning, but it's also a model of search because alternatives are being generated over time. This is the simplest possible way I can think of connecting the two. Right? And I'm not saying it's the simplest one. This is the one I can think of. So maybe you want to think of a way of making it even simpler. So I would start with something like that and then try to add some sophistication by saying two things. Can we add in a degree of exploration in the choice? So use softmax instead of max. And second, can we start updating beliefs on these things? Right? And you can immediately see some interesting things will happen. Suppose I picked action 2 here and took some random prior on it, and I ended up with a poor performance. I would automatically go pick a third action and add it to my set, right? That's how the model works. But if in addition, I also updated my expectation of beliefs for 1 and 2, it actually changes the probability of my picking the third action, right? As opposed to if I didn't change it, because the third one is drawn randomly. But if these two are also being updated, it's going to change the relative probabilities of picking these actions. So your behavior will look different. It will still have this aggregate signature that, I only search when things look bad, and when, if performance is good, I don't do anything. It will still have that property, but the specific way in which you will choose and what outcomes you will end up with can look quite different. So I'm just suggesting these as some possible ways in which you can take this basic framework and extend it, but there might be others as well. Okay, any thoughts, questions, comments? Yeah, Shukti, go ahead.
So Phanish, this is more of a clarifying question. So because here the probabilistic search is based on the on having like an extra bucket of choices, if you like, since all alternatives are known, right? And there is no sense of distance between them. So let's say our beliefs are fixed, then when we go and choose these like alternatives from the actions available, we don't discriminate, right? So it's almost like a local search all the time because it's known and I'm at random picking. So my first question is then here, in order to really add the element of exploration or exploratory search within the context of probabilistic search, do we need to create some sort of distance between these choices, wherein if like having distance, so then the farther you go, the more you're exploring?
Yes, can also. No problem. So the way to do it is in this bucket, you might actually take these actions and put them in some space, right? And you might sample from proximate if the performance shortfall is small relative to aspiration. And if the performance shortfall is huge with respect to aspiration, you might go sample from a distance.
Okay.
So we could build that in exactly into the structure of that bucket.
And instead of that, the other way to do is what you said, that if we update our beliefs instead, then already we are assigning different values, which means the probability of sampling these becomes different.
Exactly.
And then when you come to probabilistic exploration, that is toying with Tao.
Yeah, like in this slide, yeah.
Yeah, so I'm still struggling a bit to fit it with the probabilistic search.
It's not probabilistic search. That was my point. So since there's no alternative generation at this point, all that's changing is, given the alternatives, to what extent am I going to increase my probability of taking an action that's not the current best one? If you make that tau contingent on the gap between performance and aspiration, then we have built a model of probabilistic exploration. Okay. To make it a model of probabilistic search, you have to make the alternative generation look different as a function of performance being below or above aspiration level. So I'm not recommending you do it. I'm saying if you do it, let's be clear what it is we've done. We've not done probabilistic search.
And so what is probabilistic exploration then? Like, what does it mean? I understand what probabilistic search is. What is probabilistic exploration?
It would be driven by the same logic, right? So we only do things which are kind of crazy seeming when our performance falls well below the aspiration level. So, let me give you an example. Let's go back to the case of diversification. So I don't need to argue that, I never had heard about this industry called blockchain. I already heard about it. It was just like something that had a very low expected payoff for me because I don't know enough about it. It's very uncertain. Okay. Now my core business is tobacco. Okay, it's doing really badly. So when things were going well, I could never convince the board to invest in blockchain. But when things start going really badly, we might be able to get people to agree that, okay, things are going badly, we need to converge on doing something different, and maybe this is the one we should try. So this would be an example of probabilistic exploration. It would be probabilistic search if I had never even heard of blockchain. I went out there and got this action called blockchain, and now I'm deciding to invest in it.
Okay. So it's like foolishness, like March used to say? Yeah.
Exactly.
Okay.
So tau in these models is a parameter that really captures foolishness. Okay, but foolishness of the wise, in the sense that it is the willingness to do something that doesn't align with your beliefs, which turns out to be wise if your beliefs are not accurate.
Yeah.
Okay,
Okay.
That's exactly the point. Yeah.
Yeah. Thank you so much.
Okay. Other questions? Sangyun, again, do you guys want to comment? This was just my riff on how we might merge these models. You guys might have other ideas. How would you do it?
At the moment, I don't have much to add. I think we're covering pretty much everything. But yeah.
Sangyun, you have any thoughts?
No, I agree with Ekin.
Yeah, I think it's a good starting point. So, maybe this is a fun thing for you guys to do. I'm hoping you guys as groups are working on the replication projects, because I really think that is important. Okay, you should try to replicate the baseline results in those 3 papers. You won't feel really like you've mastered this content until you kind of struggle on your own. We have the code, we can share it with you, but it's best if you first try. Okay, if you get stuck, reach out to Ekin and to Sangyun, they will try and help you. And if not, we will just share the code with you eventually. But that is a crucial part of the learning. So do try it, okay? If having done that, you still have time on your hands, then I think this is an interesting project to also consider. How would we take the same basic framework of ARL, but now add in a model of probabilistic search? Okay. Hopefully this discussion also shows you that it's actually quite easy to connect different model families by changing the structure of the model and the assumptions we make about it. But in the end, that's not what will get us published, right? There is no prize for writing a paper saying, I found a way of incorporating probabilistic search inside a bandit, or incorporating exploratory search inside, probabilistic exploration inside a traditional Sayat and March kind of model. What's the insight? What new learning about the world have we got from this? That's really the key question. So I don't know the answer to that yet, right? I've just shown you mechanically how one can incorporate these elements. Will it tell us something new? I don't know. And what do you mean by new? It's not enough if we just get a new kind of a result or a different pattern in the graph or a different function of some kind. It's got to be able to explain something in the data that we could not explain earlier. Right? That's the only reason to do model innovation. So as an editor, when I was actively editing for Org Science, I used to handle all the modeling papers. I did it for about 10 years. And the most typical reason for rejection for modeling papers is the novelty was in this layer. People would say, oh, I've taken NK and I've added tau into it. Good for you, buddy, but it's not rocking my boat. No, this is not really doing anything. Or I've started with Band-Aid and I've now added some network structure. It's cool, you can do this, but we're not running an algebra department here. So what you have to tell me is, what did I learn about the world from doing this? And learning about the world really means what pattern in the data could not have been explained until your model came along, or what new prediction are you making that can be falsified in the data. That's also fine, right? It's not like we have wonderful data on everything. So it's a very high bar to say you can only publish a model if it explains an unexplained pattern in the data. There are often no patterns, as you can see from the chapter you read. The effect of how to combine individual social aspirations all over the map. There's no strong pattern, right? But at least some attempt to link this exercise on the modeling front to something that is in the world of data. Without that, novelty is not going to be judged just from the technicality. In our field, I think it can be different in other fields, right? So in parts of OR, parts of game theory, I think you can publish a new model just because it adds something technically interesting and new. Our field is not there, and I think it should not be there, because it's a risk of then you get this peacock's tail type problem where there'll be an escalation of sophistications in the model, but they become more and more disconnected from reality. Right? In the end, we're doing all this just to understand the world better, not to play with the models for their own sake, even though that is fun. So that's one exhortation I will give you. Do try to play with the idea of taking ARL and adding or using that to incorporate probabilistic search, but that cannot be an end in itself. It's fun as a project for a class, maybe as a fun way to spend a Saturday, but it will only become a publishable piece if you can show me what new insight we got out of that, and insight being defined as what does it tell me about existing data or about the kind of data I should now collect to verify or falsify the model. Okay. All right. Let me just show you, for the sake of completeness, one version of probabilistic exploration. Okay. So it's not even strictly probabilistic exploration, because this only works if aspiration level is defined as prior period performance. But what we have here are results from the complexity papers. We've already seen this probably. Where on the left you have accuracy of beliefs, on the right you have the probability of picking the best alternative, what we called search success in the exercise last week, right? That's the same thing as the one on the right. And you can look at the different performance outcomes when there's no exploration, so not softmax, but max. There's exploration, but the tau is changing over time. How is it changing? Tau, because performance is always between 0 and 1, we hardwired it to be 1 minus performance of the previous period. Which means if performance is 1, tau goes to 0. If performance is 0, tau goes to 1. In other words, you explore more if your performance is poor. Right? That's really the same as saying, if you assume aspiration levels are prior period performance, then this is a model of probabilistic exploration. And it does very well. And the intuition should be clear why it does very well, right? Because unlike the case where the tau is fixed, this is tuning itself based on performance. If tau is fixed, you get the exploration exploitation trade-off, right? That you, if tau is low, then you don't explore enough. If it's high, then you keep exploring even after you found the best thing. But if it's endogenous to your performance, then obviously performance will get better. That's what this is showing. That's why the case with endogenous tau tends to be doing so well in both these pictures here. Okay. All right. Let's stop there.